Hello friends, let's do two-dimensional projectile motion analysis in this video. Let's start with understanding this diagram. So there is x-axis, there is y-axis. Those are the two dimensions we are playing with. The acceleration that is involved is represented by this, which is of magnitude d, g in the negative y direction. An object has been thrown from point O, which is the origin in our coordinate system that is drawn here. It is launched at a speed v naught and an angle theta naught from the x-axis. The time of flight is capital T. So t equal to 0 is when the projectile is thrown. T equals capital T is when it lands again on x-axis, given the acceleration in the downward direction. Then I cap is the unit vector in the x direction, and j cap is the unit vector in the y direction. We'll use vector notation for analysis. Let's see how that goes. So we can obviously say that based on the things that have been given to us, that the acceleration vector in play here is minus g j cap. There is no acceleration in the x direction. The only acceleration in the y direction is of magnitude d in negative y direction, and the unit vector in the y direction is j cap. We also know that acceleration equals d by dt of velocity. Or we can write this as, in our situation, minus g j cap is d by dt of velocity vector of our projectile object. And we can say that minus g j cap integral of dt between time 0 and any arbitrary time t equals integration of the velocity between time 0 and t here. So what this becomes is minus g t j equals velocity at time t minus velocity at time 0. We can write velocity vector at time t equals velocity vector at time 0 minus gt j cap. Now let's think about what is the velocity vector at time 0. Time 0 is when this object has been launched at angle theta naught with speed v naught. So if we analyze that, so this is the x direction, this is the y direction, this is the velocity vector at time 0, magnitude is v naught, and this is angle theta. The x component of this vector is v naught cos theta naught I cap, and the y component of this vector is v naught sin theta naught j cap. What this implies is that this diagram implies that vector v naught, the velocity vector at time 0 is v naught cos theta naught I cap plus v naught sin theta naught j cap. So we can take this and substitute in this equation. So we get velocity vector of the projectile object at time t equals v naught cos theta naught I cap plus v naught sin theta naught minus gt j cap. At any time t, the velocity vector is composed of the component of velocity vector in the x direction summed with component of velocity vector in the y direction. So what this essentially is saying that vt equals vx t plus vyt vector addition. Comparing these two equations, we can say that velocity vector in the x direction is v naught cos theta naught I cap, and velocity vector in the y direction is v naught sin theta naught minus gt j cap. Speed in the x direction as a function of time is magnitude of velocity vector as a function of time, which is clearly v naught cos theta naught. So we can see that speed in the x direction does not vary with time, which is intuitively true as well, because we said that in our assumptions there is no force considered in the horizontal direction. So the initial speed in the x direction, which is v naught cos theta naught, stays the speed in the x direction throughout the flight of the projectile. Similarly, speed in the y direction as a function of time is the magnitude of vector y, and which is nothing but v naught sin theta naught minus gt. Now let's do calculation of position vector. So we have y-axis, x-axis. The projectile takes this path. At any time, if this is the position of the particle or the object, then this vector here is the position vector of the object at time t. This will be the x component of the position vector time t. This will be the y component of the position vector at time t. The rate of change of position vector is defined as velocity. Now we know the expression for the velocity vector. We have arrived at it here. So we can say that d by dt of rt equals v naught cos theta naught I cap plus v naught sin theta naught minus gt j cap. If we do the integration, we'll get integration of rt between times 0 and t equals integration of v naught cos theta naught I cap dt plus integration of 0 to t v naught sin theta naught j cap dt minus integration of gt j cap dt. Left hand side is rt minus r0, and this becomes v naught cos theta naught t I cap plus v naught sin theta naught t minus half gt squared j cap. What is r0? So the object was thrown from 0 origin at time t equal to 0. Object is literally at the origin. So r0 is basically a 0 vector. So this is a 0 vector, and hence rt minus r0 is nothing but rt is v naught cos theta naught I cap plus v naught sin theta naught minus half gt square j cap. The x vector position as a function of time is v naught, sorry, I missed a t here. So let me fix this. V naught cos theta naught t I cap. So position vector x, x component of the position vector as a function of time is v naught cos theta naught t I cap, and y component of the position vector as a function of time is v naught sin theta naught t, so t missing here as well, minus half gt square j cap. Let's calculate maximum height. So we know that at maximum height, at this point, all the velocity of the object is in the x direction. The y component of velocity is basically 0 at this instant. You see, everywhere else there is some component of velocity in the y direction at any random place, but at the highest point, the y component of velocity is 0, and hence the magnitude of y component of velocity at this point is 0 as well. So let's say the object reaches this point at time t1. Y vector of velocity at time t1, its magnitude is 0. Now we know the expression for v by v1 from v by t from here. This v naught sin theta naught minus gt. So this implies that v naught sin theta naught minus g, and we are saying that t1 is the time, so gt1 equals 0. This implies that t1 equals v naught sin theta naught by g. Maximum height is nothing but magnitude of the y vector at time t1. t1 is the time when y becomes h. Magnitude of y becomes h. At this time, this is the y vector, y t1, and its magnitude is clearly h. Now y t1's magnitude is nothing but this expression. So v naught sin theta naught t1 minus half gt1 square implies that v naught sin theta naught t1 minus half gt1 square equals h. h equals v naught sin theta naught t1 from here, v naught sin theta naught by g minus half g t1 square is v naught square sin square theta naught by g square, and this is v naught square sin square theta naught by 2g. Let's calculate time of flight. time is 0 here, and time is time of flight when the object reaches here. Yeah. At this point, when time of flight, when the flight is finished and time is equal to time of flight, the magnitude of the y component of the position vector is 0. Magnitude of y vector at time equals 0. So if we try to solve this, we know the magnitude of y vector is v naught sine theta naught t minus half gt square. So v naught sine theta naught t minus half gt square equals 0. T times half g t minus v naught sine theta naught equals 0. The solutions to this are t equals 0 and t equals 2v naught sine theta naught by g. T equals 0 is obviously not the answer because that is not when the flight finishes. So the flight finishes the other value of time t for which this equation is correct. So the time of flight is 2v naught sine theta naught by g. Let's now calculate horizontal range. This distance is horizontal range. The position vector at this point is fully along the x-axis. Or the x component of the position vector at this time, the magnitude of the x component is nothing but r. So r is nothing but magnitude of x component of the position vector at time t. R equals, now magnitude of position vector at any time t is v naught cos theta naught t. So this is v naught cos theta naught and the time is t, capital T. So r is equal to v naught cos theta naught and the expression for capital T is 2v naught sin theta naught by g. So this can be written as r equals v naught square 2 sin theta naught cos theta naught by g, and there is a trigonometric equation which says that 2 sin theta cos theta is sine of 2 theta. So r is equal to v naught square by g sine 2 theta naught. Let's analyze maximization of horizontal range. Let's say I'm throwing a ball and my aim is to maximize the horizontal distance of the ball on the ground. So based on my athletic abilities, let's say I can only impart a speed of v naught on the ball, which is what given v naught means, a given v naught. The other variable I can play with is the angle from the ground at which I throw the ball. So what should be the value of this angle to achieve maximum range? So based on this equation, we can see that r as a function of variable theta is v naught square by g sine 2 theta. One intuitive way to quickly solve this is we know that sine of any function, it could be theta, 2 theta, 5 theta, whatever, the maximum value of sine of any angle is 1. So the graph of sine theta is this, where this is 1, this is 0, this is minus 1, this is on the x-axis is theta, this is sine theta, this is 0, this is pi, 180 degrees, this is 2 pi, etc. So the maximum value is 1. Maximum value of r for any angle is when this thing becomes 1, and hence the maximum value r max is v naught square upon g when sine 2 theta equals 1. So theta is something between 0 and 90 degrees. Sine 2 theta is 1 when implies that 2 theta is 90 degrees. Because at 90 degrees, sine of 2 theta is 1, and hence theta is 45 degrees. So r max equals v naught square by g at theta equals 45 degrees. This concludes the analysis. Let's look at some of the key results we have obtained, and in subsequent videos we'll solve some problems. So let's recap. So to recap, we are analyzing 2D motion of a projectile, where the only acceleration of interest is g in the downward direction, in the negative y direction. So we started with stating the given in a mathematical form, which is acceleration vector is minus g, j cap. Then we used this physical principle. This is a given. Then we use the physical principle that acceleration vector is nothing but rate of change of velocity vector with respect to time. And we wrote that mathematically as at equals d by dt vt. We did some mathematics, some calculus, and then arrived at the value of velocity vector as v naught cos theta naught I plus v naught sin theta naught minus gt j cap. And we analyzed to calculate the position vector, and the physical principle we used is that the rate of change of position vector with respect to t is the velocity vector. We have already calculated the velocity vector. So d by dt rt is the velocity vector. We did some mathematics and arrived at the expression for position vector. Is composed of, and by observation we can see that it's composed of motion in the x direction without acceleration and motion in the y direction with constant acceleration of g in the negative y direction. All right, so after calculating the position vector, we went for some specialized results like calculation of maximum height. For that, we first observed that the vertical speed at this point is 0, which gave us the time to reach that point from original point as this, v naught sin theta naught by g. And then we said that at that time, when the particle reaches here, the maximum height is nothing but the value of the y component of the position vector at that time, which is expressed in this way. And then we substituted the value of t1 and then arrived at the equation for maximum height based on the given parameters v naught, theta naught, and g. Then we calculated the expression for time of flight by observing that when time is equal to time of flight, the y component of the position vector is 0. Its magnitude is 0. So that the value of that time is 2v naught sin theta naught by g. Then we calculated horizontal range by observing that when the object reaches its ultimate point on the x-axis, the position vector, the horizontal range at that point is nothing but the magnitude of the x component of the position vector. We solved this by substituting the value of time of flight, because by this time of flight is the amount of time that has elapsed. And using that, we calculated the expression for maximum range. Then we also calculated for a given initial speed, what is the value of theta or the launch angle to maximize the horizontal range. And we use the property of sine function to arrive at the result here. So the maximum value of sine function is 1. So to maximize our theta, v naught, the maximum value has to be v naught square by g, because any other value of sine to theta which is not 1 is going to lessen whatever is this value. So r max is v naught square by g. And when does that happen? When sine 2 theta is 1. And when is sine 2 theta 1? Given in our situation, theta can be only between 0 and 90 degrees. Theta is equal to 45 degrees. So this is the last result. This concludes the analysis video. We'll follow it up with some problem solving videos. Thank you.